Assalamu alaikum. Welcome to our video on binary subtraction. In this video we will dive into the fascinating world of binary arithmetics and learn how to perform subtraction using the binary number systems. Binary subtraction may seem a bit intimidating at first, but don't worry. I will guide you through step by step, making it easy to understand and master. Binary subtraction is an essential operation in digital logic and computer designs, as it allows us to perform various calculations and manipulations in electronic systems. Understanding binary subtractions is crucial for anyone interested in the inner work of computers and digital circuits. So whether you are a student, a computer enthusiast, or just curious about binary numbers and how they works, you have come to the right place. Let's embark on this binary subtraction journey together and unlock the secrets of binary arithmetics. Are you ready? Let's get started. Before going into binary subtractions, we will recall a simple questions at decimal numbers, and here we will clear some concepts, or I should say that we will recall some concepts. We are given that we have to subtract 2523 from 7392. So here the unit will be 7392. So let me write it, and this will be the subtraction. 2523 is subtrahend. Subtraction always gets started from rightmost. So look at this column. We have to subtract 3 from 2, which isn't possible. That's why we have to borrow 1, and it will get, this 2 will get 12. So as 1 has been borrowed from this 9, so this 2 will become 12, and this will be 8. Now when we subtract 3 from 12, we will have 9. And now in this columns, as 1 has been borrowed to previous column, that's why 8 minus 2 will get us 6. Now here 3, I can subtract 5 from 3, so I have to borrow 1 from this 7. So as a result, this will become 13, and this 7 will be 6. Now 13 minus 5 will give me 8, and 6 minus 2 is 4. Okay, that's what we have done. This is what we call simple subtraction. Now I want you to look this question carefully, as these concepts will work in binary numbers as well. So we have to understand some, or we have to take some concepts from this question. Look at the rightmost column macroscopically. Let me make the columns. This one is units columns. This one is units 1 columns, and this one is tens column. This one is 100 columns, and we can write it as 10 square is equal to 100, and this one is 1000 column. 10 raised to power 3 or 1000. Look at this rightmost columns macroscopically. What I was doing earlier, initially I was taking out this 3 from 2, which wasn't possible. So I borrow 1 from next column. Did I say I borrow 1? Oh yeah. Okay, fine. Let me explain easily and more simple way for better understanding. This rightmost column is up 1. You know that. Next one is up tens. What does it means? That I take 1 borrow from this column. So when I take 1, it means that I'm taking 1 10, 1 and 10 to this column. On more simple way, I should say, like, this is $10 bill. Let's say this is $10 bill. This is dollar bill. So what if I say I take $1 $10 bill to this column? So in this column, that one $10 bill here will be equal to $10, and when that $10 is added to 2, that's make it 12. Okay, so we did it so earlier, and here we were left with 8 as $1 bill has been borrowed to this one. So here we were left with a $10 bill, and from which we were taking out 2, so we were left over with 6 $10 bill. Then move on to this one. Here what was initially we doing, we were actually taking out $500 bills from $300 bills, which wasn't possible. That's why we borrow one from this column, and when we borrow from this column, we actually borrow we borrow $1,000 bills to this column. So when this one which we borrow from this column to this which was of $1,000 bill, so in this column that will be equal to $1,000 bill. Okay, so and we already have $300 bills, and when these 10 added to these 3, that's get us $1,300 bill, and then from that $1,300 bill we take out $500 bill, so we left with $800 bill. And similarly here 6 minus 2 are from $6,000 bills, we take out $2,000 bills, and we left over with this $4,000 bill. So this was the answer. Now this same concept can be used in binary subtraction as well. One more thing is we were performing these subtractions in decimal number system which has a base 10. When we take borrow from next column to previous column, it turns out to be this 10 as I explained in this column and in this column. Therefore when it comes to binary number which has a base 2 or radix 2, when we will take borrow from next column to previous column, it turns out to be equal to its base as here, and in binary numbers they to taking borrow from next column to previous columns will turn out to be equal to 2. Now let's see it through examples. So let's summarize what we have done here, or make a quick so-called formula for binary subtraction. Now here you can see this is a column of one's units are 10 raised to power 0, and this one is 10 raised to power 1, and this one is 10 square or 10 raised to the power of 2, and this one is 10 cube or 10 raised to power 3. These are the columns. When I take borrow from this column, so actually I will take 1 into this 10 to power this, whatever the power may be. So we have to translate that into when 1 is multiplied with this one, power of 10 to this column. So in this case it is 1000. So I have to translate 1000 to this column, but I can't write it as a whole. I have to transfer, or another way to write this 1000 can be 10 into 10 square. So we already have this square over here, and I can write this 10, and then this 10 can be added to coefficient of already existed unit. So let's say we have here we have the coefficients a, b, c and d. Okay, so when I take borrow 1 from here, so it will be d minus 1, and then this coefficient will be added to already existed coefficient which is 10 plus c. Okay, now again similarly, if I have to take borrow from this column, for this column I have to take 1 borrow, and this one will be multiplied with the power of 10 over here. In this case it is 1 into 10 raised to power 2 or 100. So there is a way of writing this 10 into 10. So this 10 raised to power 1 has already been written here. That's why I have to write it 10. Now this 10 will be added to already existed coefficient of unit. That's why it will be 10 b plus 10 or 10 plus b. Okay, and same comes for this as well. Now for binary number, the same rule over here will be applied. This is for decimal, and for binary the same rule will be applied, but there is only a change of number, that is instead of 10 we will have 2 over here, so it's 2 raised to power 1, 2 square, 2 cube. Okay, and again these are the coefficients. Let me change the color of ink. B, this is C, and this is D. All A, B, C, D will be in binary number systems. These will be zeros or 1. We know that a binary number is represented in this A sub n. Okay, so this is binary representation of binary number. I have discussed this in my first lecture, so I strongly encourage you to watch my first lecture of this series, where you will come to know that how we have to write these binary numbers or the representations of a binary number. Now come to a main point. When I have to take borrow for this column from this column, for this column, I repeat, for this column from this column, what I will do, I will take 1 from here. So as a result, this coefficients will be decreased by 1. So as I told you, it will be 0 or 1, and I have to make it sure if it's 1, we can take borrow from 1, but don't be confused, get confused. I have to stay with this same concept. So D minus 1, and then 1 will be translated to here, but what, 1 into 2 raised to the power cube are 3. So I have to translate here 2 raised to the power 3, and but I can't it as a whole over here. I have to write it as 2 cube 2 into 2 square. So this has been already written, you can see. So I have to write it 2, and this 2 will be added to this already existed coefficient. Okay, so that's why this must be 0 for binary numbers. We know that. Here we will have like this one. Now we have 2 into this thing. Again, if I have to move, again I have to take borrow from this column to this column. So as a result, what will happen, this coefficient, whatever the sum may be, usually it will become 2. But when I take borrow from here, I will do what? I will take borrow 1 and 2 raised to the power 2. So I will take this one. So I will take borrow of to this one, but I repeat, I can't write that over here. I have to write it in this format. That's why 2 square can be written in 2.2 raised to power 1. So this is already been written. So I have 2. Now this 2 will be added to already existed coefficient. Okay, so same applies for this first column, rightmost column as well. Now let's do our questions by these principles. In our example number 1, we have 1 0 1 1 0 1 minus 0 1 1 1. Okay, so let's solve this one, and if I have to write or make its columns as subtractions, binary subtraction can always be performed in columns. Now this is 2 raised to the power 0, this is 2 1 2. These are called weights of these coefficients, 4 and 2 raised to the power 5. Okay, now this is the coefficients of this one, this is the coefficients of 2 raised to the power 1, this is the coefficient of 2 square, and so on. Now here I have to take 1 out of 1, so here I will get 0, and here I have to take 1 out of 0, which is impossible. That's why I have to make carry, and when I have to make carry, now remember what I have to take from this column, 1 and 2 this thing. So as I told you that this 2 square can be written as 2 into 2 1. So this has been already written here. So when I take borrow from this column to this column, it will be 2 and 2. This is already here. Now this will be added to this 0. So which will get us 2 plus 0 is equal to 2. Now 2 minus 1 will get us 1. Okay, so this was the original value. Now as this one has been borrowed and the leftover here is 0, for this 0 I have to take 1 out of this 0, so I can't. That's why I have to make borrow, and to do so I will have to transfer this 1 into 2 cube. But remember, I can't write that 2 cube in this format, so that's why I can write it 2 into 2 square. That's why this will be 2 plus this 0, which is the coefficient, not this one, as this has been borrowed to this column. Now we have 2 plus 0, so 2 plus 0 is 2, and when 1 is subtracted from 2 we will get 1. Okay, now here this one has been borrowed, so we have 0, so we don't need to write anything for this thing, but as a result I will 0 minus 0 will get me 0, and when there is no more columns and the subtrahend, that's why we can mark these zeros. Now 0 minus 0 will always be 0, and 1 minus 0 will get me 1. Okay, so this is the answer. And if you want to verify your answer, you can do it by simple things like 2 into 2 raised to the power 0, this will be equal to 1 into 1 will get us 1. 0 into 2 will get us 0, plus 1 into 2 square is equal to 4. 1 plus 1 into 4 will get us 4, plus 1 into 2 raised to the power cube is equal to 8. 0 into 2 raised to power plus that will be 0, and now this is equal to 32. Now add these, we will get 45, so this one is equal to 45. This is in decimal number system. This is equal to, again, now this into this is equal to 1 into 1 will get us 1, plus 1 into 2 will get us 2, and this one 4 plus 4, so it's equal to 7. When 7 is subtracted from 45 we get 38. So is this equal to 38? So this 2, then now this one, this is already 0, so there is no need to write its multiplicand, so only the ones. This one 2, and this one which is 4, plus 1 and 2 plus 32, so 36. Yes, this is also equal to 38. You see, you can verify your answer by this method. Example number 2, let's make it. I am sure you will have learned a lot from here. That's why I ask you to subscribe my channel for more such tutorials. Starting this column, rightmost column will be equal to 2 raised to power 0. This is to 1 in this rightmost column, so 1 minus 1 will get us 0. 1 minus 0 will get us 1. Now the thing is over here. Now look at this one. I have to take 1 out of 0, which is not possible. That's why I have to search out for borrows in this column and next column. Oh, there is no. That's why I have to go to this one. From this column I have to take 1 and 2 raised to the power 4. So when this has been translated over here, so it will be like 2 raised to power 4, 2 into 2 cube. So when this one is come over here, let me change the color of the ink so that you can know. Now when this, so I have to write 1 into 2 raised to power 4, so it will be 2 raised to power 4, but as I told you, this can be right, so this is already been written over here, and 2 will come, so that's why I have to write 2 plus 0. Okay, now when I have 2, that's why I have to borrow, as I have to perform subtraction in this column, so I have to take 1 borrow from this 2. When 1, so I let me write this one. So when I have to take 1 plus 1, so this one I have to take it 1, this one will be borrowed to this, and over here I will left with this one. Okay, so after borrowing 1 from this column, I will still have 1 left in this column. When this one into 2 raised to the power cube, this will be written as 2 cube, so 2 into 2 square, so I have to borrow 2, and this 2 square has already been written. That's why 2 minus 1 I will get 1. Now for this one I have left with this one, so 1 minus 1 will get me 0, and this has been carried, so no more columns. So let's start solving our question. Here the mu unit is 1 0 0 0 1, and the subtrahend is 1 0 1 1. Starting from our rightmost column, 1 minus 1 will get us 0, and again I have take 1 out of 0, which isn't possible. That's why I have to search for borrow. Is there or no? We don't have over here, so we can borrow from here. is here. Oh no, so that's why we have to search for next column. So there we go. Now from here I have to borrow this one into 2 raised to power 4. This will over here it will be like 2, and when this 2 raised to power 4 comes to this, it will get 2 into 2 raised to power 3, and from this 2 we will take 1. So the leftover here will be 1, remember 1, and from this 2 we take 1 to this. So 1, when 1 is going to transfer to this column, it will get multiplied with this power of 2. So here we will, as we are taking 1, so 1 into 2 raised to power cube will be come to this, and now in order to write it, I will write it as 2 and this 2 raised to power 2. Now from this 2, okay, which is 1 plus 1, I will take 1. Okay, so the leftover here will be 1, and this from this 2 I will transfer 1 to this column, but this 1 which is going to be borrowed to this column, it will get multiplied to this power of 2. So it will be 2 into 2 raised to power 1, which is already been written. So 2 minus 1 I will get 1, and now I have to take nothing from 1, so I will get 1, and now this 1 left in this column, so I have 1 minus 1 give me 0, and this has been borrowed. Okay, so this is the answer. Okay, now this example for here the main unit is 1 0 0 0 0, and the subtrahend is 1 1. So it now I hope after all such hard work I put into this tutorial, you will have no more complaints or earlier that binary subtraction is a sort of intimidating at first look. But I hope now you will have mastered it, inshallah. Now from here I can see that I can take 1 out of 0. That's why I have to look for next column, which isn't anything available to be borrowed. That's why I have to go on next column, no, nothing here, and so I get something in this column. So when I have to take this borrow, so as I told you, I have to take this 1 into 2 raised to power 4, and here it will be written as 2 cube. Now this has been borrowed to this one. Now from this 2 I will take 1, and 1 into 2 raised to power cube, so I will here have 2 again. So 2 raised to a power cube can be 2 into 2 square. These are equal, and from this 2 the leftover here is actually 1. Okay, so 1 has been borrowed to this one, you know that. So this is 1 we have, and left in this column, and 1 from this has been borrowed to this column, and by borrowing means that 1 will be multiplied with this power of 2. Now from this 2 I will do what? I will take 1, so the leftover will be 1, and now this one, when it's going to borrow to this one will multiply with this one, so 2 square can be written 2 into 2 raised to power 1, and when this one has been borrowed to this column, I will get 1 in this column left, and this one will be from this 2, it will be translated by getting multiplied to this power, so I will get 2. Okay, now 2 minus 1 I will get 1, 1 minus 1 will give me 0, and as we don't have anything over here, that's why I can put zeros for absence of numbers. So 1 which is left in this column, so 1 minus 0 will give me 1, and for this as well, and now this has been borrowed, so this is the answer. Now this is last example of this tutorial. I will not let you go with any unsolved example, I should say like that, so at least we should include decimal in our example. So here the unit is 1010.010, and the subtrahend over here is 111.111. Okay, the presentations are binary number, as I told that you have to watch my first lecture. I will try to include its link in the description, so do search and the descriptions that how decimal numbers this point presentations of binary numbers happens to be. Now let me write its powers of 2's to this one. It will be like 2 raised to power 0, 2 raised to power 1, 2 square, and 2 cube, and on right side of this point we have to write 2 minus 1 2 raised to power minus 2 and 2 raised to power minus 3. Okay, now we have to take start in solving this question. And the rightmost corner, look at this one. I have to take 1 out of 0, which isn't possible. That's why I have to search for borrow from next column. I do have borrow, it is capable to borrow me. That's why 1 and 2 raised to power minus 2 will be transferred to this one. But how can I write it over here? So the simple way, now this is 2 raised to power, okay, so 1 multiplicative identity, this is 1 and 2 raised to power minus 2. And if I have to write this one, so I can write in so many ways. 2 by 2 is equal to 1, and it will be as it is, so 2 raised to power minus 2. Now I have to write this 2, and it has a power of 1, and when anything that moves from denominator to numerator, it will be added. So I can write it as 2 minus 2 and 2 raised to power minus 1. So I will not write these two to these one, as the bases are same. We know that their power will be added, so I have to write it as this thing. So now this 2 raised to power minus 3 has been written here, and I will write this 2. So look at this one. Now this 2 you come to know, I'm sure. So the leftover here will be 0. Okay, so in this column is 1 has been borrowed, so we have 0 in this column, and now this has been borrowed to this rightmost column. Now 2 minus 1 get me 1. Okay, now the same phenomena or same principle applies to all our such things. Now whenever I have to make borrow from next column, so what will I do? Now here I don't have anything, so that's why 0 is what I have in this column, so I can take 1 out of this 0. That's why I have to search for borrow next column. No, there is no borrow, it's not capable to be borrowed. That's why we have 1. Now come to this one, and it will be 2 from this one, so the leftover will be 0, and here I will get 2, and when it is come to this one, it will be 2, and when it comes to this one, so it is also 2. So the phenomena or the principle applies to all of such things. So now 2 minus 1 will get me 1, and here 1 has been borrowed, so the leftover here is 1. Now 1 minus 1 will get me 0. Point will retain its place. From this 2 we have been borrowed 1, so the leftover is 1. Now 1 minus 1 will get me 0, and as I don't have anything over here, as this one has been borrowed to this one, that's why I have to go to this one. So when it comes to this, so the leftover here will be 0. Now 2, and from this 2, 1 will be left in this column, and the 1 will be transferred to this one. Now 1 minus 1 will get me 0, and 1 minus 1 is 0, 0. Okay, so we have 0.011. This is the answer. Now it's time to get ready to unleash your binary subtraction skills. I challenge you to tackle these exciting binary subtractions problems and show up your mathematical prowess. Dive into the worlds of zeros and ones with enthusiasm and solve these questions to reveal the hidden pattern of binary arithmetics. Let's see who can conquer these challenges and become a binary subtraction champion. Don't wait. Grab your thinking cap and let's dive into the exciting worlds of binary subtractions together. See you in next lecture. Bye bye.